Defining a class in Java. Whenever you start with this, defining a class, you first need to know what are the elements available in particular one class. So let me list over here. Any class having the 7 elements. The first thing you can say that, and that is a instance variable. Instance variable is the variable that is declared in a class as an instance. Another variable is known as that is a non-instance variable. It is known as a class variable. So second copy is known as a class variable. The third point is known as a instance methods. Each and every class having these 7 features. Instance methods, you can say class methods. Same way, initializer block is there, initializer block, and same way you can say class initializer block is there. And the 7th member of the class is constructor. These are the 7 members you can say. 8th member you can say that is a nested class. Other than these 8 members, nothing there is in a class. Let me explain what this instance variable is. Whenever you declare any variable inside a class without a static keyword, it is known as an instance variable. Some system and some authors always says that this is a non-static variable. Some of the authors says that this is the static variable. Both are same. If you says that it is static variable, then also it is same. If you says that it is class variable, then also it is same. Some people says that it is non-static method, and some people says that this is a static method. So if you says that static method, or if you says that class methods, both are same. Initializer block is the block which executes every time just before the constructor is called. So for each object, if you think that I want to initialize something, for each object initialization, you can use the initializer block. It will be execute every time whenever the whenever the object is created. One more is there, class initializer block. It is also known as a static block. Constructor. It is again a used to initialize the value of the instance or class variable. So definitely it is used for the initialization. Definitely we will discuss about this today. Nested class, we will discuss about this topic in very detail in next subsequent class. So today we will discuss about these 7 elements of a class. Interestingly, the concept is what? Whenever you talked about a static, you can say that a static means it is common to all. Whenever you says that it is static, it means it is common to all. For example, if in our home we have a television is common to everybody, then you can say it is a class variable. Everyone can access, right? And everyone can have a remote. Anyone can switch on, anyone can switch off, right? Because it is a common, you can say, amenities between all of us in our home. That is a class variable. Instance variable means it is a separate copy for each object. For example, you can say that it is a individual copy for each object. For example, if I have a mobile, the same mobile, it's the same company, but the different mobile piece, you can say IMEI number of my mobile and IMEI number of my wife's mobile, both are different. Why? Because we both are using the different mobile. It means that it is an instance variable. For each variable, separate copy is generated. So I'm starting with first two right now. Let me give you an example. Defining a class in Java. So I'm just writing here comment that slash star star slash. Let me save this demo3.java. Now I just want to define that what is a instance variable. Instance variable is the variable. It is a variable which is declared in a class as a non-static. It means you need to access this using object only. For example, if my class is demo3 and if my another class is that is a test demo3, I have a main method. Now I am declaring a variable over here that is integer I is equal to 100. This is non-static variable and it is declared inside the class. This is the reason why it is known as a instance variable. Suppose I am writing here like this, demo3 is equal to new demo3, d is equal to new demo3, right? Let me give you some meaningful example. Instead of demo3, I'm just writing here that is a class that is a mobile, right? Now I have integer mobile code string mobile name integer. You can say price of a mobile. Might be a chance different handset having the different name. Now I'm writing here this is the demo3. Now I'm creating an instance mobile1 is equal to new mobile. So these are the three elements. You can say all this variable is instance variable. All these variables are instance variable. But I am declaring another variable that is integer price and I am declaring it as a static. If I am declaring it as a static, it means it is a it is a class variable. So whenever you declare a variable as a static, you can say it is a class variable. In a class as a static is known as a class variable. So class variable will be common. For example, see, let me say is that I want to create a two object, one mobile. You can say this is the M1 mobile for my wife is accessing this, and this mobile that is M2 mobile accessing me. Now I am writing that M1 dot M code is equal to, for example, I am writing 123. It means this is the mobile code of my wife. I'm writing here M code is equal to that is 456. It means this is the mobile code of me. So there are two different model and both having a different mobile code. So it is an object. For example, so it is an you can say instance variable. For example, I'm just printing M1 dot mobile code and I am printing M2 dot mobile code. Both will have the separate copy. Let me show you here. Java C demo3 dot Java. You can compile and check. 1, 2, 3 and 4, 5, 6 both are the different mobile code. But what if I am accessing a instance variable over here? For example, see here, I'm saying that m1 dot price is equal to 10,000. And if I says that m2 dot price is equal to 15,000, it means this variable will be common between all the objects, and that is the reason why this variable will be common between all the objects, and that is the reason why all the objects can change this, and that is the reason why the same copy of that particular variable available in all this. And suppose if I am printing both over here, suppose if I am writing m1 dot price or m2 dot price, here I will get that final price, and that is 15,000. See here, this is what the static is. It means static having the same copy, that is, you can say common copy for every object. So this is the reason why, see, you can say that instance variable is individual things, and you can say static variable is, that is a common thing. Suppose if I have a remote and if I uh, turn off my TV, then definitely if other people come and make the TV on, then whenever I am getting, it will be on. Why? Because it is a common, and if it is a common thing, then all the peoples can access, and at the final stage, whatever you did any operation, it will be considered a final. So my M1 having the price that is 10,000, but M2 having the price that is 15,000. So finally, it will consider the 15,000. One more thing about the static is what? You can access any static variable with the name of the class. Why? Because the class variable, you can say static variable, it has a common access to each object, and that is the reason why no need to create the object. Without creating a object, you can access a static variable. Without creating a object, you can access static variable or class variable. So class variable will known as a static variable. So if you want to access over here, suppose I am accessing system dot out dot println mobile dot price, and the same time I'm accessing after updating this. So it will give me first 10,000, then it will give me 15,000, and finally it will give me 15,000, right? So here you can understand that you can access without creating an object directly, but you cannot access like this mobile code. For example, if I'm writing M code, it will give me an error. This is the basic difference. This is the basic difference between static variable and non-static variable. See this error carefully. This error says that a non-static variable cannot be referenced from static context. Let me write over here. This is the universal truth, and this is the point to remember, that a non-static variable cannot be referenced from static context. Why? What is the reason behind this? The reason behind this is, let me show you over here. Whenever the execution is going on, first portion is executed, that is not instance variable. The first portion that is executed is a class variable. So you can say that whenever the code is executed, whenever the class is loaded, your class variable will be loaded. So class variable is, for example, you say that a class variable is released in 1985, right? Suppose if you are releasing instance variable, then after you can write the instance variable. So if you are writing an instance variable in a 1995, right? So here in 1995 you can access the property of 1985. It means you can access a static into non-static. But remember, you are trying to do what? You are trying to access this 95 element into 1985. It is never ever possible. Why? Because the class variable is loaded first. You can say that a static context is loaded first. So first of all, your static portion will be executed. So you can say that the static is executed in 1985, right? Now I am saying that a non-static is executing in 1995, right? Now you cannot access the non-static in static. Definitely yes. Why? Because the non-static is released in 1995, say for example. Then static is released in 1985. How can we access the concept of 1995 in 1985? Yes, definitely we can access this concept over here. So I'm writing here just for the example to understand the concept. So you can say that a non-static variable cannot access from static. Yes, it is true. We cannot access non-static in static, but we can access this static in a non-static. How? Because whenever you are in 1995, definitely you can access the event of 1985 over here. Suppose if we are right now in a 2020, it means if I am in a non-static, then I can access the event of static, and that is the reason why using object I can access the price, and without creating object I can access the price. Why? Because the static is loaded first. So here you can say that a non-static variable cannot be referenced from static context, but remember, a static can be referenced from non-static context. Vice versa is not true. Static can be referenced from non-static context. For example, see, this is my static variable, right? So I can access static over here. This is my method is static, right? So main is a static. Here in main, you cannot access non-static directly. For that, you need to create the object. And without creating an object, you cannot access it directly. So first of all, you just need to understand what execution order. First is static variable. You can say that the class variable is loaded first and then your instance variable is loaded. This is not the correct sequence again. Let me write the correct sequence over here. First of all, let me write the wall sequence over here, and then I want to discuss about the each and every point. First sequence is your class variable. It means your class variable will load it first. It means you can say that the static variable will be loaded first. Then your static block will be loaded second. It is known as a class initializer block. Let me give you example over here. For example, let me save this program as demo3 dot, this is demo3, demo4 dot java. Now I'm just removing all these things. I'm just creating a class, and that is a demo4. Now let me write the variable, that is class variable and static block. See here, I'm just writing another class over here, and that is a class test. Or you, without creating a class, let me write here, that is a static block. Static block you can write directly with you can write static keyword and then simply curly braces, two curly braces. Static block is the block which will be executed only once. It will be execute only once whenever class is loaded. So for example, if the class is loaded, at that time only once it will be executed, without calling it will be loaded, right? So if I am declaring a variable static integer I is equal to 50, then this I will be accessible over here, right? So you can say that your static variable is loaded first and then your static block. I am not calling this static block yet, but still you can find the result over here. Let me write here java c demo 4.java. Not a single line I am writing in this main, not a single line, but still you can say that if I'm writing java demo 4, I will get the message that it will be executed only once whenever the class is loaded, and 50, I'm not writing a single line in a main. Without writing a single line in a main, your this static block is executed. It means no need to call this portion. It will be executed whenever you are writing it, right? And it will be, you can say that this is the common to all, and this will be again load only once. Whenever the class is loaded, it will not be called again, right? Now you can say that this is my static block. It is called just before the object creation. How can I access the non-static in this static, right? And this is the reason why non-static cannot be referenced from static, because non-static is not comes into the picture yet. For example, suppose if I am writing here integer p is equal to 100, then this is my instance variable. You can say that it is not common to all, it will be individual copy, right? So which portion will be executed? A third point, right? So you can say that the third point will be loaded, that is a method, and that is a static method. But remember, a static method will not be called until and unless you call it. So it is need to be called. If you are calling this, it is need to be called. If you are calling this, then it will be called. For example, let me write here static method. For example, I'm writing a static void show, and here I'm just giving the message that this is just a show method, right? So this method will not be called until and unless I call him. See, Java C demo 4.java, Java demo 4, it will not be called. But if I says here simple so, it will be called. And you can access directly your static member over here, because this your main is also a static. So your main is static, that is the reason why you can directly write show and your show will be called. But remember, if you are writing here, even you can just print your variable system.out.println. If it is the same class, then you can access your I also. See, Java C demo 4.java, Java demo 4, this I50 is accessible. It means in static you can access every static member. One point you need to remember, that is what, in static you can access all static member, but in static you cannot access non-static. For example, suppose if I am declaring here integer p equal to 100, then I cannot write like this access the p. If you are accessing the p, it will give you an error, and the error is non-static cannot be referenced from static. Why? Because this is static, it will be load whenever the class is load, and this is your instance variable, it will not be load whenever the class is load. So to access this, you need to create a instance. So new demo 4, you need to write over here. If you write over here, then and then you can access this, otherwise you cannot access this. So what you need to understand, that a first portion is that is executed, that is static variable, then static block, without calling this both are executed. This static method will be called even only if it is called. The third portion, fourth portion, that you can say that, and that is executed from now instance variable, you can say. The fourth portion is the instance variable. You can say that it is a non-static class variable. Non-static class variable is known as a instance variable. It will be loaded whenever the object is created. So it will not be common to all. It will be individual for each object. The fifth portion that will be executed, that is as the same as the static block is there, but it is a common copy to all the members of the class. Same way, there is a one more facility available over here, and it is known as an initializer block. Initializer block is individual copy for each object. So this is the block, you can say that a non-static block. Simple. It will be executed every time just before the constructor is called. Let me just write here. Now you can say that this is my portion of the static. Now I am writing a portion of the instance, that is a initializer block written directly without writing any keyword. See here, what is the difference between initializer block and class initializer block? Class initializer block having the static keyword, while initializer block having no keyword. So you can directly write here, this is the block, this is the block, it will be executed, it will be executed just before, it will be executed every time just before a constructor is called. So whenever your constructor is called, just before that particular thing, your initializer block will be called, and here you can access your P. And one of the good thing is what? One of the good thing is what? Whenever your instance, that is, you can say that a initializer block is executes. Let me write here sequentially so you people can understand it very well. Whenever your class initializer block is executed, that is a static block, at that time your instance variable is not in a picture, but here you can access both. Even you can access I, even you can access P. So I am accessing both, that is a instance variable, as well as I am accessing the non-instance variable, that is a class variable, and both can be accessible over here, that is in an initializer block. And one more thing is that, and suppose I am writing here void display, this is, you can say, non-static method. So my sixth category is the non-static method. Again, it is need to be called, and it requires an instance to call this. One of the good thing is what? First three features. These three features can access directly without creating an object. You can access this without creating object. You can access this, and these three things you must need to create the object. You must need to create an object. So without object you cannot access 4, 5 and 6 this. Without creating an object you can access this 1, 2 and 3. One more thing, this 3 is common for each object. So this 3 is common for each object, and this 3 is individual for each object. So suppose if I says that suppose if you are writing a database connection, then your database connection you can write in a static block. It will be common for all the objects, right? And whenever you are starting, you can just make the individual copy. For that you can use the instance variable, initializer block, or non-static method. See, this is my non-static method, so I'm just writing this is just display method. But remember, you cannot access the same way you are accessing a show. You cannot access a display over here. Display will give you an error. Display will give you an error. Why? Because you cannot access the non-static context from static context. That error will become. See, non-static cannot be referenced from static. Why? You all knows very well, static is the point that executes first, and this is the non-static. So I need to create an instance Once I create the instance new demo 4 dot display, I can access this. So to call this display function, I need to create an object, and then I can access this. One more thing is what? Which portion is execute first? Your class initializer block, that is static block, is execute first, but static block is getting the variable value. It means your static variable is execute first. So let me show here. Class variable is execute first, then your static block, and that is the reason why class variable value class variable value 50 is available over here, that is in a static block. The second point is it will be executed every time just before the constructor is called. It means which portion is executed over here, and that portion is here. See, I just need to do what? I just need to write this over here. Now you can execute, and you can see that the sequence is coming over here. It will be executed only once. It means initializer block, class initializer block, it is 50. This is just a show method. It means a method is executing over here. Now I'm accessing 50, that is my instance variable value, using the object. Then whenever you are calling the constructor, just before the constructor, every time just before the constructor is called, your instance variable is called. Sorry, initializer block will be called. See here, I am writing new demo 4. So before this new demo 4, this initializer block is called, and before this new demo 4, this initializer block is called. So this is the reason why I am getting the 2 times message, that is this will be executed just before the constructor is called. Now for all this constructor, you can provide the different value to different variable. For example, see, but before that I just need to show you the concept of constructor. So up to this, if you have any questions, then you can ask me. Otherwise, I want to launch the 7th category, and that is a constructor. Up to this, do you have any questions in sequence? Do you have any questions in sequence? Students, remember this is known as a class initializer block. Is everyone is over here? Yes, sir. Great, great. Okay, so if you have any questions, then you can ask me. This is the block. Whenever you are writing simply curly, it is known as a initializer block. Whenever you are writing a curly with static, it is a class initializer block. Class initializer block will call only once. Initializer block will call every time just before the object is created. These are the 6 points that you need to understand. If you have any questions, you can ask me. Otherwise, I am just moving towards the constructor. Questions, Hardik? Okay. Yes, yes. Yes, sure. Sure, sure. Definitely, I will give. Sure, sure. Even you can take the screenshot just now. Okay. Now, let me discuss about the 7th point, and that 7th point is what? That is a constructor. So before discussing about the constructor, you must need to understand why constructor is required. So let me save this program as demo 5. I don't want all this right now. I just want to start from very scratch, and we will cover all these things in one example. Yes. So this is my demo number 5. Why constructor is required? For example, see, if you have a class, the good practice suggests that create the 2 different class and then move ahead. For example, if my class is employee, right? And this class is demo 5. Now I'm writing here integer employee code, string employee name, integer salary. Now I'm writing the employee constructor. Why constructor is required? To initialize all this variable. For example, see, to access all these things, you all know very well, I cannot access directly employee dot e code. Why? Because this e code is the instance variable. You can say that it is a non-static variable, and that is the reason why I cannot access it directly. So I cannot write like that employee.e code is equal to 101. I cannot do this. Why? Because this is the static context and this is the non-static variable. So I'm writing java c demo 5.java c. Non-static variable is not accessible over here like this. So you just need to call a constructor. So I'm just calling the constructor that employee even equal to new employee. Now you can write even dot e code is equal to, for example, 1111. Even dot employee name is equal to, for example, that is Ram. Even dot salary is equal to, for example, 50,000. Now see, you can access all this and even you can print all this also. So I'm just printing even dot e code. Even you can print all these things at last. Even I already explained you guys, that is the concept of toString. So without writing all this, you can write the you can implement the toString method. So I'm writing here Java C demo 5.java and I'm writing here Java demo 5. Definitely I'm able to access all these things. Suppose if I have another variable that is a employee of which college or which organization. So I have a static string organization name, right? And that is, you can say organization name is equal to, and you can say that it is AI, or you can say that it is training hub, right? Now see, this will be accessible from here. So I can just access simply system dot out dot println. Using object even you can access even dot organization name. Using object you can access organization name, and without creating a object you can write employee dot organization name. This is the basic difference between instance variable and class variable. But what the problem is? The problem is this is the concept that is accessible to each and every object. So might be a chance, then there is a one more employee is in the queue. And the another employee is employee 2 equal to new employee. So another employee having also the same information, the employee number 11112, Sita is the name. Now the salary is 43,000. It means for my each instance variable, the separate copy will be generated, and it is proved. It is proved that a separate copy will be get it. You will be able to get over here also using even dot, and now you are writing e2 dot. But you are writing only employee dot organization name. It means organization name is constant thing. But see, I need to write here e2 dot, right? So if I'm writing here e2 dot, see, understand the scenario. This is the 1111 RAM 50,000 training hub is the thing that is common. And where it is common, might be a chance somebody can change this, right? So if after the employee dot organization name, now my employee 1 is changing the organization name. Employee 1 dot organization name is equal to, for example, the name is now training Canada, right? So I just change using the object E1, and that will be the change copy will be available to E2 also. See, I just change, so I just change using the E1, but E2 will be able to access this. Why? Even if you are writing here E2, then also you will be able to access this. Why? Because it is a common copy. So before printing this, if you are changing, if you are changing, then it will be changed to both the instance, and you can see that if one instance is changing the value, another instance will get the thing. But if I am changing here, instead of Ram, I am writing here Ram Kapoor, it will not make the changes into record of Sita. It will change the record of only Ram. This is the basic difference between instance variable and class variable. So whenever your class variable is static, might be a chance other person can access it, and might be a chance other person can change this. So the good thing is what? Whenever it is a static, the good practice suggests that make it final. When you make it final, your variable will not be allowed to change the value. For example, if I'm writing here Java C demo5.java, it will not allow you to change the value of final variable, and that is the reason why you will be able to access only, you will not be able to change. And if you are not able to change, then and then your static value that will be accessible, and you can say that is training hub, right? But what the problem is, see, from here I am changing the value. If it is Ram, I am changing the value, that is Ram Kapoor. So I don't want allow user to change the value, and I don't want allow user to make the value. So I want that the everything should be done in a some procedure way. So whenever you want to convert it into some procedural way, you can implement the constructor. See here, this is the constructor. Default constructor is always there in any Java program. So if you are not implementing any constructor, then by default there is a one constructor is there. But you can declare the constructor with the parameterized constructor also. So for example, I'm just writing here what, see, I'm implementing the constructor but with some parameters. So instead of writing all this variable over here, providing all this value over here, I will declare the variable over here, that is integer employee number, string employee name, integer salary. So this is my formal parameters. You can say this is my variable name, and this is my instance variable. All these are my instance variable. This is my class variable. You can say this is my constructor. Now I want to do what? Whenever user providing this value, I don't want to provide the value like this. I just want to pass this value in a constructor. So you can pass the value in a constructor, and your constructor will assign the value to your variable, right? So you need to call the constructor, and after calling the constructor, you can access even.code name and salary again. Again, you can access all these things, a organization name. Now again, you can pass the same thing, that is Asita and 43,000. So no need to initialize from here. You can directly pass in a constructor. How to do this? So very simple. This is your variable e code. You are accessing your e code. It means this is my employee number. So this will be the value of employee number. So you using assignment operator, you need to write like this: e code equal to employee number. So this your employee number 11111. It will be assigned to your variable e code, right? Then you can write e name is equal to employee name. So your this employee name will be assigned to your employee name. This is your instance variable. You can write salary is equal to salary. So this is your salary variable will be assigned to this sal variable. Earlier we talked about a public string to string. So using to string you can print the instance also. This is my class demo 6. Let me show you it is working properly or not. Using constructor, your program will be simplified as well as your value will be available in your class and your class can control the data, right? So now from here, see, now still I am able to change the value from here. It means that I should not be able to. And one more thing, I don't want to print all this variable. Whenever I print only one instance, that is E1, then all the names should be displayed. Whenever I print E2, then all the object should be displayed. So whenever you want to print an object, you can implement the method that is public string to string. This is the method available in object class, and object class is the super class of every Java class. Suppose if you are not writing public string to string, and if you are writing demo6.java, and if you're writing Java demo 6, then it will print here the object like at the rate. Why training a hub is printed? Because it is a static variable and I'm accessing directly using the class. So it is by default calling the toString method of object class. But if you say is that I don't want to call the method of object class, I want to implement over here. And if you say is that return testing, so it will print the testing every time whenever your object is called. So whenever you print your object, it will print the testing. So instead of printing the testing, you can return here value, that is E code plus some value, because E code already having the value and that you have retrieved from the main. E code, E name, and you can write a salary. Now the biggest advantage is what? Whenever you, it is a cell, right? So biggest advantage is what? Whenever you print your object, it will print the wall record. See, 11111 Ram Kapoor 50,000. Now static variable demonstration is not required. So I'm just putting the comment. See here, now it is the perfect record. There are two records and both the record is visible over here and you can pass the value. But there is a problem over here, and the problem is what? Once your variable is available in this even, and if I say is that even dot employee code is equal to 1112, it means I am changing after the procedure. This should not be never be done. For example, see, if you have an identity card and identity card having the number, once the number is generated, it must not be modified. Once the number is generated, it must not be modified. But what problem is available over here? Whenever I says that E code is equal to 1112, I will be able to access and see here the number is changed, that is 11112. I don't want that this number should be changed from outsiders. It means it must be assigned through constructor. Outsider can never ever change this. Whenever you want to do this, you can declare your variable is a private. Whenever your variable is a private, it can never be accessible from outsiders. Let's see. For example, if I say that Java C, this is demo number 7. Suppose if I say that Java C demo 7.java, see, E code has a private access. It means you cannot change from here. So you need to fill up the form, you need to go for some procedure, and then you can do this. It means outsider can never can access this. Yes, you can do this. If you want to change this, then you need to implement some method, and that in that method you can update this. So that particular method you can provide over here. So you cannot do this. So here you can put the comment. But if somebody says that even dot employee name is equal to, for example, instead of Ram Kapoor, I'm writing here that is for example, Ram testing, right? I'm changing the name. So I will be able to access the change the name. So whatever the variable is required, demo 7. See, Ram testing is there. So here also you can make the private. Here also you can make the private. Whenever you declare your variable as a private, that particular concept is known as a data hiding. That particular portion is known as a data hiding. It means it will not be accessible directly from any program. You need to, if you want to access this private variable, then you need to use it in this constructor only, right? So this will not be allow you to change this. If you want to change this, if you want to change this, then you need to call the constructor. That's it. Now, one more version that suppose if anybody says that, suppose sir, I want I don't want to declare a variable same name, right? So here let me save it as demo 8. What is the difference between the demo 7 and demo 8? Very simple it is. The demo difference is this employee number. I want to declare the employee number. Instead of employee number, I want to declare the same variable, that is e code. I want to declare the same variable that is as available over here, that is ename. And I want to declare the same variable that is available, instance variable, that is cell. So definitely I need to write e code equal to e code, ename equal to ename, and cell equal to cell. So which value will be assigned to which variable? So this is your formal variable. Your formal variable value will be replaced with the formal variable, and that is the reason why this value will not be assigned, and as a result you can see that your actual value will not be still initialized, and it is 0 for the integer, it is null for the string. So your actual value is not initialized yet. Suppose if you want to access your instance variable, and if it is an ambiguity between the variable name, for example, here e code is there, here also e code is there, then to initialize your instance variable, you can use the keyword this. So this is used to initialize your instance variable. So this is the keyword that can be used to initialize your variable, and as a result, whenever you execute this, you will be able to find it out over here. Now, somebody says that I am not able to change the name over here, but what if I want to change? What is the procedure to change the name over here? So I want to change the name of employee. The good practice suggests that never make your instance variable public to everybody. Make it private. It means it is an abstraction. It will not be allow other user to access this. But you can access this by implementing the getter and setter method. So how we can do this? Suppose if you think that I don't want the allow user to change the code, but if he gives the proper application, then I want the user to allow the change the name. I want the allow to user to change the salary, right? So whatever you want to allow user to change, here you can implement the getter and setter. How? See, this is my variable that is private. It means it is private variable. So one of the biggest advantage will be what? Even you cannot access directly. Suppose if you says that even dot salary, you cannot access the private variable directly, it will give you an error. See, this is Java C demo 9. Yes, it will give you an error. Cell has a private access. It means you cannot access the salary of anybody directly. So you are not allowed to access the salary. You can access this, but if you have an access of his method, right? So using that particular method, if you are accessing, then you are allowed. So how to write the getter and setter? You can write the data type, that is integer. So return type should be integer. This is the cell, that is your variable name. So you can write simply get, and then your variable name, that in a capital letter as a method name, proper convention style, you can write get cell, and simply you can return a salary. One of the biggest advantage is what, for each object you will be able to access the salary. So you can write here even dot cell get cell. This is the function, right? You can write even dot get cell. Here you can write e2 dot get cell. It means you will be able to access the salary of the person. Yes, even dot get cell and e2 dot get cell. So using the function, I can access this, and the separate copy will be written. See, 50,000 and 43,000. Why? Because this my salary variable is instance variable. So without proper style, you cannot access this. Same way, suppose if anybody says that I want to access the even dot get employee code. So employee, even you can write even dot employee code. Even dot employee code, you cannot access this because it is a private. So whenever it is a private, you cannot access this. You need to write the same method, e code, that is integer return type. Return type is integer. You can write a get e code, and you can return, that is your e code. Now you can write a function, that is get e code. So whenever you write the function get e code, you will be able to access the e code of the first record and the salary of the second record, right? Now this is what the you can access the integer. But how we can access the string? Very simple. String is the return type, data type. So you can write the function string, then your variable name is ename, so you can write get name of an employee. So return ename, so it will return the instance. It means without this function, so user will be able to access this. User will be able to initialize using constructor only. User will not be accessed directly. So you can write here get ename, and you will get the name of the first employee and salary of the second employee, right? So name is Ram Kapoor, salary is 43,000. 43,000 is the salary of the second employee, and the name Ram Kapoor is the name of the first employee. So I'm getting the name and code and salary. But if somebody says that, sir, I want to change the salary, or I want to change the name, definitely you are not allowing me to change the code, but I want to change the name. So whenever you want to change something, this is what you can write a get. Now how to write a set? So you can simply write a function, that is void set. Whenever you write get, it means it is returning something. Whenever you write set, it means it is setting some value, right? So user will provide me the value. So here you can write a set cell. Now you just need to provide the data type over here, input, and data type will be the as same as this is salary having the integer data type. So you can simply write set salary integer salary. So whatever user is provide, you can simply write this dot salary equal to salary that whatever user provides, right? So now here you can set the salary. For example, I'm simply writing here even dot. Let me print even first. So I'm just printing even. So this is the actual record of even. Now I'm setting the salary even dot set salary, and I'm making the salary is 1,20,000, right? And now I'm accessing the even again. You can see that no need of second record just now. Yes. So I'm just executing Java C demo 9, Java demo 9. See, there are two records. The first object is printing the old salary 50,000. After changing the salary, it is 1,20,000. It means the salary is changed. Even if I am not able to access the salary variable, even if it is, but if it is big, I don't want allow to user to make the salary that is a bigger than 1 lakh. Then what to do? Then you can now it is in your control. So you can write simple condition. If salary less than 1 lakh, if salary less than 1 lakh, then do this. Else, simply print the message. You cannot enter more than, you cannot enter greater than or equal 1 lakh. It means you cannot enter more than 1 lakh or even greater than or equal 1 lakh. So if now I am writing here salary that is 1,20,000, it will give me an error. I need to save this program. Yes, at which position it will give me an error? Whenever I run this Java demo 9, see, the old salary is 50,000, new salary is also 50,000. You cannot change, you cannot enter greater than or equal 1 lakh. It means if you are entering the salary, if it is big, then you are not allowed to change. But if you are making here 99999, then definitely it will allow you to do this. And the new salary is changed. So this is the way you can deal with the object. That is this is the way you can deal with your instance variable. The same way that you set the salary, you can write here void set employee name. For employee name, or variable name is a string employee name. So you can write here string employee name, and you can write this dot employee name is equal to whatever the user is providing to me. Just put it to that particular variable. Now using this procedure, not only salary, I can set the name also. The new name is, for example, testing. So before changing the name, it is Ram Kapoor, and after changing the name, it is testing. This is the new salary, but the code is the same, and you are not allowed to change the code. Why? Because I had not implemented the method to change the code. I had implemented the method to get the code, but I had not implemented the method to change the code. And if method is not implemented, it means you are not allowed to do this. This type of concept is known as a encapsulation in Java. What is encapsulation? Encapsulation means whenever you are declaring your variable as a private, and using getter and setter, you are allowing user to make the changes, and accessing of the variable is known as a encapsulation. Whenever you declare your variable as a private, you can say it is a data hiding. And this is my constructor. Using constructor, I'm initializing the value. So whatever the user is providing to me over here, that will be assigned using constructor to my variables. So if you have any questions in this, you can ask me. This is the way we will develop every program like this. We will develop our every program like this. You first need to identify, for example, see, you need to do what? Employee. So it is a name of table. Employee number, employee code, employee code, employee name, and salary. So you need to do what? This is your variable. For example, PCS salary is 72, KKS salaries, for example, 84. So this is my variable. It will be declared as a private only. You can insert the value into this using constructor only. You can change the value of this variable using setter method only, and you will be access the value using only getter method. This is the proper style of writing the code in Java. Now I want to teach you the correct sequence of each and every object. So let me write Java demo 11, and I'm just removing everything from here. This is Java demo 11, right? I'm declaring a class over here that is a test. Now I'm declaring a variable that is a static integer s is equal to 20. Integer I is equal to 40. This is my static block in which I'm just printing the message class initializer block, and I'm accessing s. Definitely I will not be able to access the I because I is my instance variable and I cannot access instance into static. This is my class variable. This is my, you can say, class initializer block, or you can say static block. It will be called only once whenever the class is loaded. Now I am writing here initializer block. Initializer block will be called every time just before the constructor is called. So I'm doing what? Initializer block. I'm accessing here s as well as I am accessing I. It means in initializer block you can access static as well as non-static. Why? Because static is loaded first, so it will be definitely accessible in the non-static concepts. Now I'm writing here constructor test. So I'm just printing the message. This is constructor. So which line will be executed first? If I says here new test. Now you people need to give me the answer. If I'm writing here 4, integer I equal to 1, I less than 5, I plus plus, new test. It means I'm calling it 5 times and every time I'm just accessing what? This is just a constructor. So your I is 40, S is 20. I am incrementing the value of I plus plus every time. And I am incrementing the value of S plus plus every time. And now I am printing both I as well as S. Yes, enough. Let me write some space. Yes, your two variable will be that is static variable having the value 20. So your class initializer block will be called class initializer block will be called with the value 20, and then your initializer block will be called with the s, that is 20 and 40. Why? Because your constructor is calling. So first time constructor when call, before that initializer block will be called. Second time constructor will be called, before that initializer block will be called. but you just need to focus over here on this increment decrement. What happens, see, this s plus plus is common to every variable. That is the result why your static variable will be incremented every time, right? And this I plus plus is the instance variable. It means there are 5 objects, then for each object the I variable will be the separate copy. So for each object I, I will be my 41. Let's see it is working properly or not. See here, for each I, my I is first, see here, class initializer block runs one time. That's fine, good. Initializer block run first, then constructor, initializer block, then constructor, initializer block, then constructor, initializer block, then constructor, initializer block, then constructor. It is also quite good. Now see here, initializer block printing 21, 20, 21, 22, 23, 24, and you can say now constructor having the value that is 25. So here, from here you can say 21, 22, 23, 24 and 25. But see here, this is constant, 41, 41, 41, 41, 41. Why? Because let me show you over here. I have 5 objects: object 1, object 2, object 3, object 4 and object 5. Each and every one having the 40 separate value. Now each and every one is incrementing 1, so definitely I have the 5 object and each and every one having the 41. But if I have the variable value that is static, and that is static having the value 20, and when I increment this, so this object will increment the value, this object will be increment the value, this object will be increment the value, this object also will increment the value. So you can say that a class variable is the common resource among each object. And you can say that instance variable is the individual resource. It is the individual resource for each object. This is the basic difference, right? So if you have any questions in this, you can ask me, and even you people understand that this execute only once, right? So just before the constructor, your initializer block runs. Even in your initializer block, you can access static and non-static. And so there are concepts like 1, 2, 3, 4 and 5. Other than this, there are 2 more concepts. One is the static method. Another one is the non-static method. But the concept is what? You cannot, this will not be called automatically. It will be called if and only if it is being invoked, right? So these are the 7 elements available in Java to define a class. I hope the concept is clear now. Is it clear, everyone? May I give you one more example? Great. Let me write here. I am calling you. Now you need to give me the correct output, which will be called first and which will be not called first. Even you need to tell me that, sir, this will give you an error or it will not give you an error. Suppose I am writing here, this is display method. Now I am writing here that this is show method. This is demo 12. Now students, you need to tell me, suppose if I am calling here display, is my program is correct? No. Hardik, why? Why? Good. Because this display is the non-static method and your main is static. So from static context, you cannot access non-static. So this will give me an error when I execute this Java demo 12.java. It will give me an error, right? Display cannot find the symbol first. Suppose if I says that the class name is test, can I write like this test.display? No, I cannot do this, right? Non-static cannot be accessed. But can I write test.show? Hardik? Good. We can write like this and your see, I had written this test.show, but your class initializer block is invoked. It means you cannot. Yes, yes, Abhi, please. Good, good. It means whenever your class is invoked, it will execute everything, right? Now tell me, suppose I am writing here 4, integer I equal to 5, I greater than or equal to 4, I minus minus. Now I am writing here new test dot display. Yes, everything is perfect. Who will tell me the answer? What is the output? Let me make it here. Integer s is equal to 50 and I is equal to 100. Instead of I plus plus, I want to make I plus equal to 2. Instead of s plus plus, I want to make is minus equal to 2. Except Hardik, who will tell me what will be the result? Let me assure you that there is no error in this code. There is no error in this code. And all the concepts is available over here, including constructor, method, block, initializer block, everything. Yes, except Hardik, who will tell me fast? Whenever you write like this, see, class initializer block 50, correct. Class initializer block 50 and 100, correct. Now 102 and 48, correct. This is display method, correct. Now initializer block is giving me 48 and 100. Why? Because this is my I variable, this 48 is my s variable. S variable will decrement the value, but initializer block will give me the same value, that is 100, right? So I is the I value having the 100, that is initializer block. That is instance variable will kept as it is, that is 100. And now it will be 102 again and 46. So it means my static variable will be common and instance variable will be, that is individual. Is it clear, everyone? Great. So now I just want to move towards, yes, somebody is asking. Yes, good. Thank you. So let me write over here the order. So whenever you get all these demo files, you will get the idea. The first will be evaluated, that is class variable, and that is known as a static variable. You can say that it will be called, you can use it by name of class. The second thing, that is known as a static block. It is known as a class initializer block. It will be called only once whenever the class is loaded. The third thing that will be executed is what? That will be the static method, but it will not be called it will be called if and only if it is being invoked. It means if it is called, then and then it will be executed. The fourth thing is instance variable. It is known as a non-static variable. You can not you can use it by object only. So with the name of the class, you cannot access this. The fifth one is, you can say that, a non-static block. It is known as a initializer block. It will be called just before a constructor is called. Every time. It will be called every time just before the constructor is called. The sixth resource that we have, and that is, you can say that, a instance method. It means it is also known as a non-static method. Again, it will be execute if and only if it is called, or you can say it is invoked. The seventh member is the constructor. Great. So now let me move towards the method overloading, right? So not method overloading. Let me talk about the method first. Then we will talk about the method overloading. Then we will talk about the constructor overloading, and then we will move towards the inheritance and all these things. So right now I just want to discuss about how to declare a method and how to call this. So very simple, it is demo 13.java class, for example demo 13. Now I'm writing here main. Now let me show you here the syntax for the methods. How to write the methods in Java. Methods is also known as a functions. Methods, or you can say it is a functions. So how to create a functions? Return type is required. Either it can be a void, integer, float, long, double, like we did in a getter setter function. Then function name. Then we can provide here arguments. Arguments with the what? That is, you can say data type with variable name, and you can write more, you can provide more than one data type also. If it is return type is other than void, if it is return type is other than void, then you can return the return type. This is the syntax of method. For example, even you can use the modifier. Modifier is optional. Here modifier can be, here a modifier may be static, final, or you can leave as it is. So it will be non-static and non-final method. For example, let me write a method over here. So I'm writing here class test void display, right? Now I'm writing here not void display, I'm writing here void calci. I want to get the two inputs from the user, and I just want to make the sum of that both number a plus b. You can simply call from here test t equal to new test, and you can call t dot calci 15 comma 20, for example. So it will make the sum of two numbers, Java C demo 13.java, Java demo 13. See, it will give me a 35. But if you says that I don't want to calculate over here, I want to return the value, then instead of calci, I just want to give another name, that is a calci2. it will do what? It will do the sum of two numbers definitely, but it will not void, it will return the value. When it returns the value, it means you will access that particular value over here. It means whenever you call t dot calc2, and if you says that 35 and 64, right? So you can write here integer answer is equal to, so your value will be returned, that is returned value will be stored into this answer variable, right? And you can print your answer variable. So whenever you want to store any value and then you want to access, right now I don't want to access, I just want to do, at that time you can do this. So basically the functions is, you can say that the function, see, this is the output. The function, that is method with no return type and with return type. Suppose the same name function is available, same name function available, but with the different data type. For example, I am making a float A and float B. So same name with the different data type. That concept is known as a method overloading. We will discuss about this in very detail in the next lecture. We will discuss about the method overriding also. Up to this, if you have any questions, then you can ask me. Otherwise, the time is over for today's session.